In previous Part 1 section, we already see examples of 2D plots in Matlab, as well as the commands we can use in Python Matplotlib library. Now we will take a look at more color field plotting in the following section, Part 2. So before we step into the field plot, which for the color, I want to just give you some idea how we decide the color in the Matlab. I show it similar to many other software or application, even the Photoshop. We Matlab try to plot the figure or plot the field by the 3 RGB triplet, like red, green, and blue. So it's a matrix with 3 columns. So for each color, or we say red, in the computer is saved in 8 bytes, and each byte is only 0 or 1. So the range for each color will be a combination of these 8 bytes. So in each byte we have 0 and 1, so the total combination was 256. That's why you see 256 when you see the color bar. However, because the index inside the computer starts from 0, so the maximum number is 255. So in Matlab, this is normalized. So normalized by the maximum number. So what you can see is just a 0 to 1 for this RGB triplet. Okay, it's not a, of course, for most of the product, the data you can download is maybe 1 to 256, but you can convert it to 0 to 55 and normalize it and use for Matlab. But Matlab already have some default color. You don't need to exactly specify its RGB number. You can just write a short name. Like previously, we used the Y represent yellow, magenta, and blue or black and you just type K on it, and the Matlab will know it. However, for the field plot, we say contour plot or some figure filled with the colors, we need to specify the color map. And Matlab has those the default color map. And if you don't specify any color map, if you plot it, they will give you a Perura as the default color map. But it used to be a jet, which is the second one. But I don't know which version is changed to this one. I don't know. And those color map is useful. However, some people, depends on their data set, they probably need a different color map. If you want to design your color map, you need to specify all of the RGB array by yourself, which is very annoying and it's not easy to do and it's not continuous, especially for some. So here I would suggest you use the NCL color map. NCL is a NCAR, which is Colorado, is an institute to study atmosphere and ocean science. NCAR command language is called NCL. This language is not supported anymore. It's replaced by Python. However, you still can use this color map because NCL provides more than 100 different color map you can use. So you just go to this website and you can see all the color map, listed right over here, okay? And you can see each sample and the different color map has different name. And you can see right over here, the first one is included 254 colors, and here is 200 colors. What you need to do is just click the color map you want and download it. Once you download it, you can see 3 columns of the array, and you just need to load this these 3 arrays into Matlab and normalize it by 255, and you can get exactly the same color map you have right over here. So like this one, I show the topography of LA County and Ventura County. So for those kind of color maps from the dark green to yellow to brown, you cannot find it in the Matlab. You have to design your own. However, for those kind of color map, you can easily to find the NCL color map. You don't need to learn this language anyway, you just need to download the color map and load it into the Matlab. So far, this is the one I know include most the largest number of color map. Probably there are something more, some website I don't know, but this one is very useful. It's not only for Matlab, you can do the same thing for Python and even R if you use the ggplot. Okay, here I give you some example using color map. So this example is spiral function. So you see the spiral function right over here. Here is the x and the y. And to plot these things, and you can see the particle. We assume this particle goes up, and I change the time as the array, and I just plot it. Here I want to show the 3 dimensions, so I use the plot 3-dimensional plot. I just type in each time step where the x is, where the y is, and I just use a solid line color blue to plot it. And the same function you can use in the Matplotlib library, but the thing is in Matplotlib library, there is no plot3, this command. So you only use the plot. However, you can change the axis. I want the projection become 3D and will look like this. And here later on, you can see one example to show you how you call these axes in the Matplotlib library. However, to show this kind of things, you don't know exactly how particle moved by time. So we can try to change the color map to see it, something like this. The same function, okay, but I want to see how the particle change with time by color. So if you just use the plot3 command and add the color on it, it doesn't work at all. What you need to do is use the same command, and no matter you want to specify a color or not, you just write it. Then you specify a color map. Here I want to use jet, which is from the dark blue to dark red, like a rainbow. So you specify your own color map, okay? Here you can see the length of t. If you remember, the length of t is how many time steps you have over there. So the thing is, if you just write, you put the jet, the color map over here, you will discretize all of the color. The default is 256 color, but I want more because I want each time step has one color. So I just put the number of the time step right over here and create my own color map. We call it CMap, and I will redraw it because I already draw it, and I just draw a new color map on the original one. So it will overwrite the original color, no matter what you specify in this command, black, blue, whatever. So he will use the new color map. So what I need to do is just change the age, change the color of this line, color binding it, and interpolate this color map. So for this, if you type this, he will use all of the things in color map, and for each step, he will fill up its corresponding color on this line. So you can do this for one-dimensional, actually the one-dimensional line. Even we see a three-dimensional, but for the color, it sees only one-dimensional line, okay? So here I want to show, previously we talked about how we download the NCL color map. Here I want to show you how the color map will change in the figures. This is one image, actually it's from the one animation. The original 256 colors in this figure. So if I just only have 128 color, you don't see the big difference. However, if you use less color, like 32 and 8 color, you can see, especially in the yellow circle, the blue has been replaced because in this figure, you only have the 8 color. So I would suggest when you download the color map, you want to have bigger colors, bigger numbers of colors possible. Say in the previous NCL color map, there are some only have 100 color. Excuse me. If you have the 256, I would suggest you use the 256. Otherwise, after you download it, you have to interpolate. You can use the in Matlab library. You can use I think interpolate one, and to find and to refine the color map. Otherwise, they will lose some resolution or lose the color for your figures. Okay. Here I don't list the command because this image processing called spatial library, so I don't list the command right over here. So once we know the color map, we jump into the field plot. For field plot, I think most of the people use the contour. So if you have 2D gridded data, which is like a mesh, you just plot the contour right over here. So you use the contour F. If you don't put F right over here, you just show the line. But if you put F, you will fill out all the contour. Here, I just want to mention one thing is because this is many people use. I think you are familiar with that. You have to put a shading flat, otherwise you will see a lot of a grid line as a black shown on the figure, and you don't see your data at all. For Matlab library, that's exactly the same command. And here is another one, we call it p-color. It's very, very similar to the contour. If your grid is fine enough. So here you just put the p-color and the same thing, shading flat, otherwise you see the grid point. And for Matlab library, it's the same plot and p-color. So the thing is, those two plots are very similar and they look slightly different. You can see the line over here because when the Matlab plot is do some interpolation between grid to grid, okay? And of course, you can here is 20 labels. You can add more and to get the final one. And the thing is, when we're gonna use the contour app and when we're gonna use the p-color, I would suggest if the data set is continuous. If your physical equation is continuous, I would suggest you use a contour app because each grid is continuous. So you use the contour app or contour to show your data will make more physical sense. However, for some image processing things, because those data is highly depends on your resolution. So if your data is resolution dependent, or like we say medical processing, like MRI or MRI scan or CT scan, we usually use the p-color to plot it because those image or those data set is resolution dependent. So you want to see, you also need to keep the resolution of your figures. So I would suggest you use a p-color. Otherwise, the interpolation process inside the Matlab or any software will mess out your plot. So for those 2D things, we can also plot the 3D. Actually, here you see the plot look like 3D. No, actually, there's only 2D plot. There's only X and Y, and there's one value on it. We just try to move the value up to the 2D plot. So we use the surface. So here is the surface plot. Use the same, exactly the same data set. You just need to plot. Previously, we plotted the X and Y, which is location of value, and you put the one value Z right over here. The same, please use the shading flat, otherwise you will see the grid. And for the contour, if you want to see the surface and the contour at the same time, you just need to use the surface field C, X, Y, and Z, the same thing. And here I want to mention one important thing in the Matlab library. If you want to generate a similar plot, first you import the Matlab library as a plot. However, because this plot function is most of the time you use it for two-dimensional. If you want to see the three-dimensional thing, you need to import another one to make sure you import Access 3D inside this your code. So you make a figure, plot figure, you put the axis. You need to make sure the code know what you're plotting. Here I put the subplot, but you don't need to do this. The 111 means you only have one plot, and your projection, like what do you see previously, you need to put the projection as a 3D. So the Python or your Jupyter Notebook knows you want to see the figure as a 3D instead of just a flat 2D plot. And we use this command plot surface, and the same variable you list over here, you can exactly get the same plot right over here. Okay, that's a little bit different from the Matlab. So another important thing is how we want to see our 3D plot. Because the 3D plot is easy, as long as you have data, you just one command, you finish it. The thing is how you want to see it. When you previously you see that the default setting for the Matlab, and you can change the azimuth and elevation angle to view it. Like I want to make the plot a little bit flat. Okay, it look flat. So what you see is right over here to see the figure. So I can change the minus 15 degree to 15 degree. It changes the azimuth angle and elevation angle. So what you need to do is just after you plot, you just type view and you can see the different angle. So here is a different angle and it really depends on what you like. So you can change it and to see which one you like. And the thing is for Matlab library does the same thing because those angle is controlled by the axis property. So you have to use X property and view initial. The interesting thing is here you can see in Matlab, you use azimuth at the first and elevation. However, in Matlab library, you have to use put the elevation azimuth in the follow. So that's a little bit different. And another thing you can change, make your plots look a little bit better is we put the light on it. Okay, here in the Matlab, the default is the camera. You can change the light. You can just type light and the direction. However, there's a camera light. You just put the camera light and by the direction you want. Here, I put the camera light right. So you can see on the right side, there's a little bit light color. Or you can change the camera light from the head, which is from the top to the figure. And you also can change the view, of course. But that kind of shiny plot doesn't look very pretty. So what I can do is we add some different material. So here I just add one more command. We say material dot. Then we will remove those shiny pattern. You also have the light. It just become like much light color. So if you compare this figure with previously that kind of things, I think this figure looks much better. Of course, you can put a color bar right over here. I just don't add it. So using this small technique, you can make your figure look much better. And the same thing for Python. So function in the Matlab library is you put, because the light source is inside color category, so you have to use another one. It's not a PyPlot anymore. You have to import from the color and import the light source. But a weird thing is in the light source, if you call the light source in the Matlab library, you put the azimuth at first and elevation. It's different from the what you view. If you use the view command, so you have to remember this and make which light source you want to put your plot. Okay, so for 2D data, we can do the same thing. And for the real 3D data, you can exactly showing the same, you can apply the same technique. Here I want to show one example is, there is a flow over the rectangular cylinder. So the flow from for rectangular over X, Y, and Z. If you want to see the streamline, the flow, what the flow look like, you just need to use the streamline. As long as you have the data, you have the X, Y, Z, which is coordinate, you have variable, which is your velocity. So using this command to show the 3D data, what you need to do is just streamline. But the thing is you need to let the Matlab know where the streamline will start. So you need to put the start point at the end. Okay, the start point is from the mesh grid command. The mesh grid will automatically generate a mesh or a grid distribution for the range you specify. Here I wanted the X from starting point from the first X, and I want every 5 Y point give me a starting point. I want every 3 Z point give me a 1 starting point. You can see these kind of things. And you can specify the color and the line width. However, for those kind of plot, it's just for viewing purpose. It's not pretty and it's not good for the presentation. So we try to make it more complicated and make more beautiful or looks better. So we use another command, the same data set, use this different command, string tube. Once you have the string tube, you have ISO surface for each particle, each flow, and you can change the color on it. This is default color for Matlab. You can change the jet or change it more or less fit your data. Here, I want to mention one thing is similar to shading flat we use for 2D data, you have to remove the edge color because in each tube, Matlab auto-generate a black surface for this tube. If you don't put edge color none, which is don't show this edge color, you will see everything's black. It's hard to read. For those kind of plot, is a little bit better than the streamline plot we see. You can more or less see the reality of the data. However, we can make it even better. We try to use the previous technique, we put a light on it. If you just type light, your light will automatically generate some surface or make your tube look like shining and it's more like 3D. However, if you don't specify the light direction, and it looks very dark. So you have to, if you use the camera light, like this one, camera light from the right, so, sorry, from the top. From the top, then you can see it's become much lighter compared to the left one. And however, the same technique, we can change the material. If you want to know more detail, you can just type help, like help material, help cam light in the Matlab. It'll give you all the description of how you use this function. Excuse me. So if we put the cam light plus material, change the material, it look a little bit brighter and make those product more or less looks good. So you don't see the change, like the red circle, you don't see the color change so rapidly in this little vortex or eddy. So that kind of technique you can apply for 2D and 3D and to make your presentation looks much better. And if you add a color bar or some index on it, next to it, that will be much better, looks good for publication. So the next one we want to talk about, so far we only use one color map. For some data, you want to have multiple color maps, 2 or 3 in the one figure to show the different information. Here I just give you one example saying I want to plot some snow over the watershed or mountain. And snow is white and the topography is like green or brown. So here is, I just pick one example. Here is I select one watershed or whatever. You just assume this is area on the mountain. This is King Canyon National Park watershed. So you can see I use the previous color map I download from the NCL command. So I plot the elevation. So from this map, you can see the elevation become higher, it become brown, and the lower elevation is green. Actually, if you add the last point, you can add one more color bar to make the river. You can see the river here. You can make the river as the blue if using this technique. So I have a snow cover, like probably next couple months, you can see the similar things. So for the snow depths, I only have up to 2 meters snow. However, the elevation is pretty high. The elevation is almost 4,000 meters. If you put the two figure in one, two data in one figure, you don't see the snow at all because all the snow will be override by the elevation. So what I want to see is something like this. I want to see the elevation. I want to see the snow over this elevation. And I want to have two color bar. One is showing the snow, one is showing the elevation. So what we need to do is the first, you don't need to have the subplot right over here. Here I just, when I write the code, I just try to make it smaller. That's why I make a subplot. The important thing is you need to specify one axis, which is one subplot or one figure. You name it as one, and then use the command we already know, like color bar. Okay, this is the elevation. And the very important thing is you need to let MATLAB remember where the map is. That's why later on, when you write the snow property, you can overwrite the same position of the first one, of the first figure. So here I list x1, which is the first figure is elevation. You just need to use the command get and the position. So MATLAB will remember the ax1, which is elevation position inside this variable. Then in the second one, you don't need to specify where is it anyway. You're gonna overlap in the first one. So the second one, I want to show the snow. So I just specify x2, which is axis. You don't need to specify location. You just pop out in the background. And I want to plot it in the color of the snow. Okay, you don't need to change the color. You just need to put the variable on it. The important thing is I want to link two at the same one. So I want to link those snow depths and elevation. So I use the link x-axis and put the two, one is elevation, one is snow together. And you said that the second one is color non-visible off because I want to remove those boundaries. Okay, if I don't write this one, and you can see the overlap, and you can see the picture doesn't look very well because it's plotted the box twice. And the third one is I add a color map. I have a different color map. I have one color map for the elevation. I have a second color map for the snow. It doesn't matter. So here I didn't show it, but in the figure you can see different color map show your different data set. And I want the two figure put together. So I set the first figure elevation and second plot, which is snow, in the same position. And where is it? You just specify the first position. So in the figure, you don't see this snow depth will show in the background. What you exactly see is there's only one, and the second snapshot was something like this. Okay. So for this kind of thing, you can add more. If you have three, like observation, point scale observation, you can put one more layer, and you can put multiple layer as long as the second one, third one, and go on can know where the first one. So this command is very important. You need to let the MATLAB know where the first one is. Okay. So those kind of those kind of technique we can apply to geographic plot. And usually we don't use the MATLAB to plot something like this. Okay, this is the like COVID-19 cases globally on November 1st. I just did a couple days ago. So if you use Python, then to deal with those data set, you may not able to use the Matplotlib library to plot this. You need Panda. You need pandas to load the data set, and you need another package called GeoPanda to show those geographic plot. And MATLAB as well, if you just install the basic library, you cannot use it. For those library, you need a geo library. That's why in the beginning I mentioned that you don't know what you're gonna use it, but rather than just select one you want to use, in case you want to use it, just install all of them together. And if you have the space, and the good thing from using MATLAB is you don't need to know which package or the NetNever package. Like a Python, you don't need to exactly know what function or what package you need to use, and you import it. Before you import it, you got to install it. But MATLAB, once you install all of the package, you just type a command on the command window. You can see it, and without knowing what exactly package you want to use. So for this kind of geoplot, you need the data, which is like a big circle in the United States. We got a very serious case. And you need the data intervals. And you also need to know what the bubble size or bubble scale. And you need the base map, which is global, or you can show it local. So how to write these kind of things? And the first one, you need to let the MATLAB know where the data is. So you need to have the data for latitude and longitude information. Now, in this example, you can download from the GitHub. I just put the latitude and longitude as a one variable. Just the first, first one is latitude and second one is longitude. So you make it a table. The good thing is you make it a table because later on the GeoBubble only can take the table variable, and that will be easy to organize. So you can have, you put these three things, three array, actually it's only three array. One is the latitude, longitude, and total cases. Here I put the index, is just I select one day, but in the GitHub data set, you can see most of the, I think you can see all of the daily data starting from the middle of March, I guess. So I put the table property, the variable name. So you just type the table property, variable name is the specified latitude, longitude cases. So you already let the Matlab know what the data is. Then I change the data. You need to categorize the data by the size. So here you discretize the table cases by all of the, how many interval you want, how many space, or the scale you want. You just type right over here, and you put the categories or categorical and put the number you see on the table. Okay, this is data interval you need to specify. And just one command, we call it the GeoBubble. So you put the GeoBubble table and give that what I want to show. I want to show the latitude, I want to show the latitude, and what the bubble represent. So the bubble will represent, the bubble size will represent the cases, which is my total cases for COVID-19 globally. And you can change the color. Like that color, I use the inverse of summer. So the color variable, so each color, so for the size variable, only show the size of the bubble. And if you want to fill up the bubble, then you need to specify the color variable based on what you specify right over here. And last one, you change the size. Okay, this size is point, I will explain later. This size is point the same as you use for font or marker size. So you can change this one. It can, I think can start from 1 and up to, I don't know what the number, but you can take a look at the plot to see if this is a number. It's not linear. So you can change the color to see what you want. Sorry, change the bubble size, okay? And once you have this selection command, you can get the previous plot. However, sometimes I don't like the gray background. I prefer the color one. So like this one, the good thing is for Matlab, as long as you connect to the internet, is get online, it will automatically download some base map when you do the plotting things. So what you need to do is just global bubble your figure and plot the base map. Like this one, I want the color terrain. So you just need to specify color terrain. You just this one line, it will automatically download the data from GIS system and give you this one. And you can also have something like you see on the Google map. So I want the serialized image, okay? Then you will provide this one for you. It make your product looks more fancy, or So, but those two commands, you need to make sure you connect to internet so you can simultaneously download the color map for you. And here I show the global because the entire data set is global. Of course, if you show the local one, if you show the local one, it will become much smaller and you can see more information on those background base map. Even you can have some street or building on it, like exactly the ArcGIS or QGIS system, the software you used. Okay, the next one is how we generate animation. And actually this is for most of a paper publication, or this one is not very important because you don't show the animation, but for the presentation or talk, to make the plot changes with time, with the data set, will be interesting and KGI anyway. So here I want to show the animation. Actually, the animation inside most of the software, it just overlap one figure by one figure. Okay. Here I give you one example is a sphere. So you know the function of the sphere. is the original. You have X naught, Y naught, and show the surface. Okay, to plot this in three-dimensional plot, here is the default function called the sphere. Actually, I think a recent version they put it right over here. Otherwise, you can write your own function inside the Matlab. It does the same thing. So the ds60 means how many grids you want on one boundary of your sphere. So I put the size of the sphere can change starting from very small one, 0.1, the radius from 0.1 to 1. And then the Matlab, I give the sphere function, it return where the point on the grid. It give me the three coordinate of X and Y, and I just use surface. Here I just show you the grid, and later on I will change the color to green, and you can see the ball or sphere right over here. So for the animation, actually what we want to do is just try to connect all the figure, or we call it the frame, inside one loop. Okay, so in individual is starting from the very small one and to the end. Here I specify 50 frames, so 50 slides. And you can show, if you plot all of the 50 together, it look like something like this. So for the animation, the basic idea is I plot one sphere, any one of them, then I get a frame which I capture. It's kind of screenshot. I get one frame for any one of the data I have. Then I convert this frame, which is this plot, into an image and save in the memory of the Matlab, okay? And once I have the image, I specify all of the color for this image. Here I specify is a green. So you need to specify is become RGB, or otherwise it's just a data set in the memory. Then you just write this image into a file. So if you do this again and again, 50 times, and play those things once, it's become imitation. So something like I show over here, you can see the bubble increase the size and bubble decrease again. Okay, this is a GIF file, so I can play it continuously. You can save it as AVI file or other format. So this is the code you need to know. The first step, you plot a sphere. And second, as I say, back to the previous slide, the first one, you need to get a frame. So the current figure, I just get a frame, make it a frame. I make the frame into the image. So I just use the command frame to image of this frame. This is the one loop. And then I specify the color for this image. So I use RGB2 to index. So you can make this number. Actually, this number is big enough. However, if you make it like smaller, it just become the less color. But I say, if there is enough resources, I would suggest use as many color map, the resolution as big as possible. So here I specify RGB color to this image. So the frame already convert to image and then specify the color. So what I need to do is just try to write the image into my file. As I mentioned, here is my file output, which is GIF. So here is the output name, okay? So here you can see the loop count. I specify loop count 0, so it will continue run repeatedly, run one again and again. So if you change the loop count to 1, it will just run once. 2 will be just replace two twice. So here is the first one. Once you have the first frame, you put the image into your file. And starting from the second one, we just try to overwrite the same figure, okay, into the same frame. So here and here is the delay time is 0.1 second. So from the first, so you can see this, it's not very smooth because I did it on purpose. If you specify the delay time right here 0, or you don't write it, you'll become very, very continuous, okay? So this loop will just show you one figure like this. And you can change this, can be applied to two-dimensional, three-dimensional figure. As long as you have this command, you get your current figure and we'll overlap one by one. Okay, this is how we make an animation. It's not hard. The thing is what you want to show and what kind of file you want to save. So the last section is important for our publication. You want to know the resolution, how your figure will look like. As I mentioned several times, once you see the figure on the screen, how we control it, we use the GCF command to control it. And this is the basic figure file. We want to save our figure, our plot. Matlab has default figure, they call it .figure, but you only can open this one on Matlab. So if you want to give this figure to somebody else, they may not have a Matlab. So we want to try to save it as a regular figure format many people knows, like a JPEG. Here is a bitmap figure, which means the figure is saved in the pixel scale. Okay, we call it the bitmap. It's including the JPEG, PNG file, or TIFF file. Okay, this is compressed file. Compressed means that there's doing some compression, so you can see the file size is much smaller. However, there are some non-compressed file. You can see one figure probably a couple megabytes, which is bigger. In the Matlab, is TIFF non-compressed, so the TIFF-N and BMP file. There is another format for the vector, for the figure. We call it the vector. It's not exactly save the pixel. It saves the command we generate the figure. So when you give this kind of thing, they need the software to open it because they only save the command how we generate the figure. It's not the pixel itself, including the PDF figure, EPS figure, or SVG figure, like scale vector. So for those kind of figure, people can regenerate it. And because they can regenerate it, so when they zoom in or zoom out, the resolution doesn't change so much. But for most of the publication, I would suggest you can use the unpressed TIFF or PNG. JPEG is too small and you will lose a lot of resolution on it. So you can do the two-way. One, you use interactive, as I say, you just use the GUI icon. Here you see the save figure. Once you have the figure, save figure. But however, if you do this, because Matlab only save the screen of 72 dpi, so what you can see is just this figure only 72 dpi. That's it. You cannot change it because he just copied everything on your screen. So another way we can save the figure, we use a command. So we use a command like we can type. Once we have the figure, like GCF right up here, your file name, and you want to save the PNG, as I mentioned, we want to save PNG or TIFF. You use the save command, save as command. However, save as command only give you 150 dpi. This is default setting in the Matlab. If you want to change it, we have to use some other things. I will explain later. So how I change the resolution, I want to specify, especially like a publication, you might probably need at least 300 dpi so people can exactly see the data you want to show on the paper. If you're using Matlab 2020 alpha version of later, I think now it's beta already released. So you can just use a command, we call it export figure. Say I want to export the figure as a test.tiff, and I specify the resolution right over here. We say 300. You will exactly output the 300 dpi figure on your screen, and as well as when you save the file. But how about if we use the older version of Matlab? Here is some example. Before we get into the print command, here is some third-party package you can use it. This package is very useful. You can try to do the same thing, mimic, export the graphic, and you can play around it, but it's not small. And those they including a lot of Matlab file to let you export different figure in different format and resolution, how you look like. So if we want to use the Matlab version before 2019, there's one command we can use. We call it the print. So what you need to do is, as I say, Matlab only see the screen 72 dpi. And when you save as, the figure only use 150. I want higher or even lower. I need to specify the image resolution. So here I use the image resolution. Here I specify my image resolution like 300, okay? And I have my file name like test. Then I just plot, I use the command print, and to make my file name as a PNG. Here, remember, you have to have this option, okay? Like a dash, dash D PNG, it will save as a PNG. And here is the resolution specified. So this is a string. I combine the two strings. One is dash R. Here is the number of image DPI. So when you see the command, it's like a dash R 300. So once you type this, you can have the 300 DPI image for PNG file and for a TIFF file as well. However, sometimes we don't exactly, we are not only want the size, the DPI resolution of the image, we want the real size of the image to show on the paper, okay? Or to show, when they print out on the printer, we want to exactly know this is like 1 inch or by 2 inch figure. So, but interesting thing is, when you're doing these printer things, we are not only specify the image resolution. So here we follow the previous command. I want a 300 DPI image for my figure. But however, when you print it out on the printer or print it out or save it out as a file, you need to use, that's why it's a little bit complicated in the beginning when we talk about the graphic environment. For those kind of things, if you want to specify, I want my figure size exactly 4 inches and 3 inches big, you need to specify the paper unit, okay? I want to specify the figure. This is the current GCF figure I have. And I specify the paper unit. Okay, I will specify paper unit as inches, okay? And the default will be a letter size. And here I use the position because this is not only decide the position of the figure, more important, it decide the size of the figure. Where is mine? Okay, so the paper position, if you type paper position, you will get 0, 0. You don't need to mind where it's pop out on your screen, but when you print out on your paper, we're starting from the x equals 0, y equals 0, and exactly the same 4 inches and 3 inches in your paper. So we specify the paper to control the size, the real size of the figure. But remember, your image DPI will be correspond or be highly correlated to your size. So when you say the print this file, you specify this, and when you use exactly the same command to print it out, you can see your figure. The pixel will be 4 inches because I specify 300 DPI and 4 inches. So your file will be exactly, I think, 1200 by 900. So you can see your file if you click the right button, and to see the information of your figure. For those kind of figure will be 1200 by 900 pixel in your computer, no matter you save it in the PNG or TIFF. However, when you print it out on the paper or the printer, will be exactly 4 inches or 3 inches. So that'll be slightly different from what you see on screen. And if you care about what you exactly print out or give the file to somebody else or for publication, this is what you need to do. Specify the image resolution and the size you want, but remember they are connected, they are correlated, and you can exactly show what you want to see in the figure.